Let's talk about the machine learning workflow and how we can use Vertex AI to build and deploy your models. There are generally 5 steps in any machine learning workflow. The first one is data preparation, usually followed by model training, after which we perform model evaluation and sometimes model iteration. Once we're happy with our model, we move on to model deployment and model serving. And once our model is available in production, we move on to model monitoring. As we get more data and as we monitor our model, sometimes we figure out that we might need to use the new data to retrain our model. Hence, we'll move back to the first step, data preparation. In general, data preparation is mostly focused on extracting and cleaning a particular dataset, performing exploratory data analysis, also known as EDA, to better understand the data we're working with and what are the various features or characteristics of it. We usually apply a lot of data transformations and feature engineering to the raw data before feeding it as input for a model during training. Most of the time, in particular for supervised learning models, we also need to split the data, usually into training, validation, and test sets. There are a few tools available on Google Cloud that can help us during this step of data preparation. If we need to explore or visualize the data, we can do so using Vertex AI Workbench notebooks. Vertex AI Workbench already integrates cloud storage as well as BigQuery to help you access and process your data faster. If you're working with larger datasets, you might want to try Dataproc Serverless Spark from a Vertex AI Workbench notebook, where you can run your own Spark workloads without having to manage your own Dataproc clusters. The model training step usually involves in choosing a training method for a particular model and/or a particular machine learning framework. Model training usually involves picking a machine learning framework or a library, after which we pick a particular model or multiple models, and then we choose a particular training method for our models and we try to tune them to get the best performance. If for our use case we want to train a model without writing any code, we can always use Vertex AI AutoML, which supports tabular, image, video, and text data. If we have the capacity to write our own training code and train custom models using particular machine learning frameworks, we can use the custom training functionality. We can always optimize the parameters for custom trained models using custom tuning jobs. If we're dealing with more complex machine learning models, we can always rely on Vertex AI Vizier to tune our hyperparameters. If we want to try multiple machine learning techniques when training our models and compare the results, we can always rely on Vertex AI Experiments. The Vertex AI model registry comes into play once you train your models and you want to version them and hand them off to production. The model registry also integrates with validation and deployment features such as model evaluation and endpoints. The third step in our machine learning workflow is model evaluation and iteration, which usually involves trying to evaluate the model that we managed to train, trying to make various adjustments to the data based on the evaluation metrics, and then trying to iterate on our model multiple times until we're happy with the final resulting model. We can use model evaluation metrics such as precision or recall to evaluate and compare the performance of our models. We can do this by creating evaluations using the Vertex AI model registry, or we can include evaluations within the Vertex AI pipelines workflows. The fourth step in the machine learning workflow is model serving, which usually involves deploying the model to production and getting predictions for incoming requests. Vertex AI gives us access to pre-built or custom containers to deploy our custom trained models in order to get real-time predictions. We can also get asynchronous predictions when we perform our inference on an entire batch of data points. For this particular use case, we usually don't require a live endpoint to be available for real-time requests. If you ever worked with TensorFlow, you might already know the fact that TensorFlow was developed at Google. So it's no surprise that Google Cloud also has an optimized TensorFlow runtime that will help you run your TensorFlow models at a lower cost than when using the open source alternatives. If you're working a lot with tabular data and models relying on tabular data, Google Cloud offers you the Vertex AI feature store, which can be used to serve features from a central repository as well as to monitor feature health. The Vertex Explainable AI tool helps you understand how each feature contributes to the model predictions and find mislabeled data from the training dataset. This is done by feature attribution as well as example-based explanations. Last but not least, BigQuery ML allows you to train models, deploy them, and also get predictions using BigQuery. The last step in the machine learning workflow is model monitoring. The purpose of model monitoring is to monitor the performance of a model that was deployed in production. To do this, we usually use incoming prediction data. We can also use incoming prediction data to retrain our model for improved performance over time. The Vertex AI tool that allows us to do this is model monitoring, which can monitor models for training serving skew and prediction drift, and can send you alerts when the incoming prediction data skews too far from the training baseline.